Great. All right, looks like we're live. Hey, everybody, it's the 30th of July, 2024, and today we are investigating one of the modules in the Plutus PBL course from Gimbalabs and Friends. We're going to work through module 203 right here, which is about minting NFTs. Last week, module 202 went live, but it's okay if anybody's here in this session, if you haven't worked up to this point in the course yet, it's okay. We're going to review a lot of ideas and have space to encounter some new questions together. The way it's going to work is we're going to look at each lesson and then look at some examples together and then do some Q&A and take it as far as we can for the next 90 minutes or so. So right here, we've got a module called Minting NFTs. And there's three learning targets. We're going to mint an asset that can't be minted again after some deadline. We're going to mint a classic Cardano NFT that complies with the SIP 25 standard. And then we're going to mint one that sort of complies with the SIP 68 standard, more kind of takes some hints about what we might be able to accomplish with some of the ideas there. Along the way, we're going to ask this question: what makes an NFT non-fungible in the first place? And so the intro is right here. You can see it on my screen. One question we might start with, because we've already been experimenting with policy ideas in this course, is does an NFT have to have a unique policy ID? Certainly, that's one way to claim that a token is unique. And there are ways to mint what's called a one-off NFT, right? That can only ever be minted once. And the way we can do that is use a Plutus script to look at the input transaction hash to a minting transaction. We're not going to look quite at that example. That's something we could look at a little bit later, especially when we get to module 205 around validator essentials. But the basic idea here is that when we talk about NFTs on Cardano, they don't often have unique, like one of one policy IDs. Often NFTs will be minted in a series as a collection. So you might have 10,000 space buds that all have the same policy ID, and each one has a different token name and different art associated with it. When we think about classic NFTs, many of them do have a locked minting policy, and we'll look at an example of that. And this just references that in a simple native script, we can put a minting deadline um, from which the policy ID is derived. And that way you have a guarantee that a certain policy ID can't be minted again. Then there's kind of cutting edge work when it comes to token naming. There's some really fabulous work being done using validators written in Plutus or Aiken that ensure the unique naming of individual tokens. That's a little bit beyond scope for this module, but I wanted to name that as something that we should definitely explore together sometime in the future. And that might give us material for some additional lessons. For now, we're going to start with the essentials. We're going to mint some Cardano NFTs. And like I said, along the way, we're going to wonder what makes these tokens non-fungible. We're going to encounter some really important concepts. One of them is transaction metadata. So we haven't covered this directly in the course yet, but you've seen some examples where it's quietly included in a transaction. So maybe you've noticed it. But if you haven't, this module is going to give you a chance to see how metadata works. Here's a really basic example of metadata. You have a key, which is also known as a public label for some on-chain metadata. And then you can attach some arbitrary data like a string or a number, or in this case, an entire object that consists of multiple key and value pairs. You can write plain JSON. So if you're familiar with JSON, you'll be able to write metadata. And when we get to NFTs in the second lesson, we'll see a much more complicated example of metadata that's still essentially structured like this. Now, those Cardano NFTs, they comply with what's called CIP 25, CIP, which stands for Cardano Improvement Proposal. And this was written a couple of years ago. You could see the date on it, April 8th, 2021, by Alessandro and Smog. So Smog built Pool PM. Alessandro built Lucid and Spacebuds and some other contributions across the ecosystem. We're not going to send him a mail right now. Okay. And we're going to dig into this in just a minute. But that's the other key concept we're going to cover is this concept of Cardano improvement proposals. You can review all of them at this URL right here, sips.cardano.org. And this is a really important piece of how Cardano development works, right? SIPs allow people to agree on patterns and ways of doing things so that they can better build interoperable tools. There are always new standards in development, and there's still plenty of need for new standards to emerge. So we'll look at an established one, we'll look at a newer and emerging standard, and then we're going to do something interesting by only taking bits and pieces of SIP 68, which is going to allow us to ask the question, yeah, are we really adhering to this standard right now? Or are we doing something else? And if we're doing something else, does that imply that some new standard is emerging? There's also a note up here that not all SIPs are the same. Some actually result in core functionality that's added during hard fork events on Cardano. So SIPs 31 and 32, which are linked right here, are examples of ideas that started out with the CIP process, but then ended up being integrated onto Cardano itself. And that's why these days it's already assumed that we have the ability to include reference inputs on validator spending transactions. And we have the ability to use inline datums, which in the early examples we've shown in this course is actually the only kind of datum we're using, right? So these are kind of historic documents that show where upgrades to the blockchain started. And this pattern will continue to happen, right? We're going to continue to see upgrades to the chain. SIP 1694, for example, will be implemented on mainnet at the time of is it the Chang hard fork that's coming up that brings us into the Conway era, right? So that's a pattern that we can count on to continue. Finally, at the end, we're going to look at some assignments, and we're in the process of finishing off some of the earlier assignments, but the idea here is that each one can propose important stuff that everyone should do, neat stuff that we encourage everybody to try, and tough stuff that provides an optional challenge for people wanting to go deeper. So I wanted to just highlight some of this stuff before we jump into the lessons so you can have this stuff in mind as we go through the examples. So at the end of this module, one thing you'll do is build a transaction that posts some metadata to an arbitrary key that on pre-prod hasn't actually been used yet. So it's empty. And then we're going to use the results of that in the next module in 204. And so this is a pretty simple description that obscures some of the challenges you might face along the way. Okay, but this is the challenge to everybody. After you go through lessons 203.1 through 203.3, hopefully you'll be able to build and sign and submit a transaction that puts some new metadata on chain. And you've got three choices of how to do it with Cardano CLI, with Mesh, or with Game Changer. For neat stuff, right? This is optional stuff that we really do think everybody can try. We'll invite people to combine what they learned in the first two lessons to build a time-locked NFT collection on Preprod, where each NFT includes a different image. For people who want to go deeper, this would also be a chance to learn a little bit about IPFS, which we're not going to cover directly in these lessons, but everything you'll see when we look at minting an NFT applies to using images anywhere, whether it's IPFS or just on standard storage. And then finally, the challenge assignment here is to try to create a full implementation of SIP68. And there's a couple of links here that people can follow through with. Now, any of these, when you get stuck on these assignments, those are great opportunities to bring questions to live coding or to the Gimbalabs Discord, or even just to other people you know who might be working through the course. And we encourage people to talk about this, to share challenges, and absolutely to share questions. So that's what we're going to do. I just kind of ran through the overview of the module and where we're going to end up. Does anybody have any questions or insights so far?
Not here. Looks good.
All right, so this is the future. This is an hour from now. We're going to be able to say that in this module we just did these three things. So let's jump in. So first lesson, minting with a validity interval. So a couple of prerequisites. In order to follow along with this lesson, you'll need a Cardano node, and you can run it locally or on Demeter.run as shown in lesson 102.1. Okay. I do have a node running locally, so I'm going to be able to demonstrate these examples on this computer. But if you don't have a synced pre-prod node, as you've seen, Demeter Run is a great option, and all of these scripts will work there. You should also have completed module 202, and we're going to assume some background knowledge. So module 202 was where we just minted some basic tokens by several different methods with Game Changer, with Cardano CLI, in the front end UI of a web app using Mesh. And then we explored a little bit about minting with a validator. So what we're able to look at is that there are some transactions. Okay, and those are only in the example, which I'll open up in just a second. So yeah, we're about to look at a transaction example that if you've already worked through module 202, it'll look familiar. Okay. What we're going to do, we're going to mint a native asset that can't be minted again. One way to make a token non-fungible is to guarantee that it can't be minted again, right? And so we have this concept of a time-locked minting policy. And in order to demonstrate this, I'm first going to run some provided scripts. We're going to create a new minting policy, mint a token with it, and then we're going to wait a few minutes until after a deadline, and we're going to try to mint it again. And we're going to see that we can't. While we're waiting, we're going to come back to some of these examples together. But I wanted to jump right in and run this script, investigate how it works together, and then show that after the deadline, it no longer works. So let's jump over to here. So I have the PPBL 2024 transaction examples repo on this computer. You can clone it as well from the link provided in the course. I'll pull the latest changes to make sure that I have them. In this case, I'm already up to date. And you can see I have some untracked files that all relate to new scripts, new signing and public keys, a currency symbol. And the scripts we're going to run right now are going to produce more of the same. Okay. All of the examples we need here are in the module 203 directory. So let's jump into there. And the one we're going to start with is this one, Mint Time-Bound NFT. Let's take a look. So there's a few things to notice here. One is that this is calculating a current slot by making a query tip call to Cardano CLI. The other thing is that there's two ways to set your address and signing keys. One, excuse me, one is to open up, or in your case, probably create a new env.sh file. I'll show you an example of mine in just a moment. Or you can just uncomment these two lines right here by deleting the comment symbols. And you can add an address. Sender is an address, and then the path to your sender key. I'm going to show you what these two look like right now. You can see that I have an env.sh file. This is included in the git ignore, so you won't find it in the repo. And if you make your own env file, you don't have to worry about that getting accidentally pushed up because once again, it's already included here. But let's just take a look at it. So I'm doing two things right here. I have a sender address, like I just mentioned, and then the path to a signing key. And if this wasn't on pre-prod, it would be irresponsible of me to be sharing my screen like this, right? I'm here on a computer that's hooked up to Zoom and I'm showing you the path to an S key. If you were a smart hacker, you could just jump into my machine, take this S key, and that's just like me exposing my mnemonics to you, okay? Um, in this case, I'm fine doing this for demo purposes, just with the caveat that I'm using a testnet address, and I would never do this if this was a mainnet address. So we've got this file set up, and let's go back and look at right here, this dot, right? This dot is pronounced source. So what are we going to do? We're going to source the env file, and then we're going to source a utilities file that has a couple of helpful functions that we'll use later in this transaction, okay? But I said we were going to run this first. And what we need in order to run this is just an address to receive the token that we're going to mint right now. You know what I'm going to do is off screen, grab the address from my pre-prod wallet that's hooked up to Eternal so we can look at the results of this. So I'm copying this. And now to run this script, right, which you can do even if you're not even sure how everything works here. We're going to look at this in just a minute. But as long as you've got the sender and the sender key loaded in, you should be able to run this script as follows. Right? So dot slash means run this script. It is executable right here. Let's mint a time-bound NFT. And remember, it took one command line argument, that $1, which is the address to which we want to send this. Oh, and of course it didn't work because it's a demo. Let's see. All right, that's wonderful. Get address biggest Lovelace. Okay, that's good. The reason this happened is because get address biggest Lovelace is in this file right here, utils.sh, which is actually in the same directory as the script I'm trying to run. Let's fix that. I want access to this function right here, but if I look at where I'm sourcing utils from, it looks like it says dot dot for the parent
Nice.
directory. So let's change
Easy,
that. There we
easy
go.
fix.
Easy
Yeah.
fix, right? So let's try that again. There we go. All right.
Okay.
So I didn't plant that error, but I wish I could take credit for
I
that. It's a
I
nice
wish
one.
that you did. Hey James, would you mind bumping up your font just a slight bit?
Oh, you
Is
got it.
that
Yeah,
is that too
no problem.
yeah, nice. Wonderful.
All right, so this prints a couple things, and now we're on the clock because we just grepped, we just grabbed the current slot of the blockchain. We did a little bit of arithmetic to create a deadline slot. We're calling this token just the deadline itself, okay? And we're going to talk about this number in just a second. And then we see that the transaction built successfully because we see the transaction fee. And then we see that it was signed and submitted successfully because of this message right here. Both of these are coming from Cardano CLI. These three messages are coming from the script that we were just looking at. Now that we're on the clock, and this thing shouldn't work again in, well, how much time is that? Let's look. So once again, this was mint, and no, mint, time bound. Okay. So what happened here? We ran a command so that we could see the tip of the blockchain. And maybe you're already familiar with this. Over here in the lesson, you can see an example. Let me just pull that right back up for a moment. So when we query the tip of the blockchain, we might see a response that looks like this. And in our script, we're pulling this bit right here, which is the current slot of the latest block at the tip of this network. Okay. And this number right here represents the number of seconds since the blockchain started running. It's a protocol parameter that a slot has a duration of 1 second. And that is a parameter technically that can be changed. I'm not sure if that's likely to ever happen, for example, on mainnet. I'm not aware of circumstances that would drive us as a community to say that a slot should be something other than a second, but theoretically it's possible to change that parameter. And I'll leave it to you as some arithmetic to figure out when the pre-prod network started. You can just turn this number of seconds into years and you can figure out that date. What we're doing is we're just running that command, and then we're using a tiny application called JQ to pull the value of slot from right here. Then, once we have that number, we do a little bit of arithmetic. Right? We say, okay, just print that to the terminal. We just saw this on the screen. And then add 900 seconds, which is equal to 15 minutes to calculate what we can call a deadline slot. Because this is just an example, that's going to be the name of our token. So we make a new directory with that name and we change directory into it. Then we create a new set of keys just for this minting policy. We calculate the key hash as you saw in module 202. For all of the files that are created, we use this variable right here in the file names so that if we run this script multiple times, we'll be able to distinguish between the different keys and scripts that have been created. And then we use a nifty little feature of Bash right here, which allows us to echo, which just means print, in between some quotation marks, an object. And then we save this object into a new file name that we've already defined up here. What goes inside of that file is a script that in previous lessons you've learned how to write by hand, but I think you're ready just to have a script like this automatically generated. The one thing that you might notice are all these slashes right here before the quotation marks. That slash is called an escape character, because think about it. We have an opening quote here and a closing quote here. We don't want the script to think that we want to stop the quote like right here, right? So what we do is we put a slash and then a quotation mark, which actually prints the quotes into the file that we're building. And I'll show you that in just a second. Okay. Escape characters. That's a really nice thing to know about if you're writing scripts of your own. Once that script is generated, we use it, right? This variable right here is exactly the same one we're passing right here. Let's use Cardano CLI, transaction policy ID, pass it this script file, which is the only parameter it requires, and save that to a new file called deadline slot.currency symbol. And that's the policy ID that we're going to mint. Finally, just some helper functions right here. Get address biggest Lovelace. That's the function that we couldn't find when utils wasn't properly imported up here. But all this does is it looks at the address that we've already saved as sender, and it grabs the biggest Lovelace only UTXO that's currently at that address, right? We can look at that script together if it's helpful, but first I just want to take it the rest of the way through here. The other thing to notice is that when we have a token name and we're using it in a script like this, we can't just use a number, right? So deadline slot was some slot number. It was an integer, but we convert it to a hex string. And if you've been working through the course, maybe you've seen that there's websites that do this, like stringfunctions.org. But we're just going to use a simple bash function right here, okay? We're going to take some variable. What variable? Deadline slot, and we're going to convert it into hex. We save it as that, and then the token hex is actually the name that goes on chain, right? It's not the name that you'll see in your wallet. If you look at this token on Cardano scan, in Nami, or in Eternal, all of them take that hex string and they convert it back into a legible string, which in this case will be the slot number. But you can see right here, now that we've prepared all these variables, here's our transaction build. This looks pretty similar to what you've seen early in the course when we were building simple transactions, and more recently in module 202, where we were minting. It adds one key line right here, invalid hereafter. And what this says is we're going to build a transaction that won't be valid after some slot. Why? Because that's the rule we set up in this script. In this transaction, we're trying to mint a new token. To mint this token, we have to satisfy these two rules. It has to be minted before the deadline slot, and the transaction needs to be signed by this new signature associated with the pub key hash that we generated right here from the V key we generated right here that is associated with this signing key. So notice that both of these rules require us to add some information to the transaction build. Hey, I want to mint this token. And I promise the transaction is going to be signed by this signing key, and it's going to be invalid after this deadline. Okay. As long as I meet those two constraints, then this will build successfully. I'll be able to sign it and submit it. How does that feel to everybody?
Hmm.
While you're thinking about questions, I'm going to open up the results of all of this. So let's jump out of the script itself. Whoa. And let's see what was created here. Okay. So first of all, you can see there's this new directory with the name of this token. Here's another new directory. This was the failed transaction. So some of the beginning of that script happened. And if I jump into that one, 9523, I will see that the transaction never happened. We created some keys, we created a script, but when we went to build the transaction, the build step failed because there was no UTXO input because we had a function that wasn't imported correctly. Let's compare that to the other one, 9605. Right. This one actually has the draft of the transaction and the signed transaction right here because it worked. And now let's run this function, query tip testnet magic 1. And you can see that now the chain is currently on slot 6666 9358. All right, we're not here yet. So it would still be possible to mint more of these tokens. Remember, let's just put that up on the screen again, but let's also open up the script. Mint time-bound token, right? This has to be minted before this deadline, which we haven't hit yet, with this key hash, which is the hash of this V key right here. And whoops, I want to cat that PKH. Oops. Let's that's kind of annoying when that happens. The solution is to do it like this. There we go. Now it's on one line. Okay, so here's that pub key hash, and it's exactly what's in this script right here. Good enough. Are there any other outputs that would be helpful to review here to make sense of what's happening?
Outputs from the,
Like any of these guys or
oh, I see.
details of the
Oh,
script that we were just looking at?
yeah. Show me again where the key hash goes in the transaction build.
Beautiful. Okay.
So,
Okay. So after we make the new directory, we just generate some keys, right? Which is wild. This part's wild to me, right? Because if you're holding actual assets on Cardano mainnet, these two things are so uniquely important to you. But they can also just be created over and over again and thrown away. And right, there's it's hard to estimate the scope. Thousands, millions of key pairs have been created and never used on Bitcoin and Cardano. Right. So
okay.
we generate a throwaway set of keys, and then we say, okay, now given that we just created a verification key file with this name, let's use that as the input to the next command, key hash, and generate a new file called same name, but with the extension .pkh. So now we have the key hash. And where is it used? Okay, once we have it, we're going to use it right here in the minting policy
I
script.
see. Okay. Okay.
This can all be done by hand as well. And right, as an exercise, this is something for us to talk about just like philosophically as we continue to build out any course material is what's the right amount of copying and pasting or just writing by hand new files to ask people to do. Right. So we're not asking anybody to do that here, but optionally, that might be a nice way to kind of build a little more hands-on muscle memory. And the experiment here is to figure out how to strike the balance.
So it takes all of that and then builds. So if you scroll down and it does it take it? Is that the only place that that key hash is used? Yeah, because
So
it just builds this
yeah,
PKH.
in
But
terms
then,
of the key hash, it is, but once we include this bit right here, we're
mhm.
locked in to saying two things. One, that in the build, this transaction is going to be signed by this signing key. Which signing key? The one associated with this pub key hash, right? All of which were created up here. Keygen, create the V key and the signing key. Key hash, use the public key to make the public key hash.
Oh, I got it. Yeah, yeah.
Then, right, this thing, right, this is the public thing. I can share my verification key or my pub key hash or my wallet address with anybody, but I can't share the signing key.
Hmm.
All right, to mint these tokens, we promise we're going to use the signature associated with this pub key hash. Don't believe us? Well, the pub key hash is public. Go look at it. And once you see it, you'll know that we've got the signing key right here. This line is not always necessary in a simple transaction. Why? Well, down here, you can see there's two signing keys, but only one required signer. This sender key right here is required because of this TX in right here. So if we're going to spend some UTXO, it's implied that we're going to have to sign for it. But separate from that, oh, for the minting part, yeah. There's going to be another signer. And here, we'll provide that signing key as well. You could have many of these in a minting policy. Then it would be a multi-sig minting policy. And there's more examples of that in module 202. Right? And if I had multiple required pub key hashes, I would just add additional required signers here and additional signing keys here. Oops. So are we getting close to that deadline? Oh yeah, looks like we're beyond it. Great.
Ah,
Okay. So enough seconds have passed. Now,
oh,
here's where it gets interesting, right? It's kind of nice to be able to and let me we'll go back and forth. Okay. So what I'm gonna do here is we're gonna what's the best way to do this? I want to use all of the same variables we were using a minute ago um, to show that I can build this transaction again. Um, and the way we're going to do this is as follows. Let's open a new tab and just throw this right here. And then I'm going to pull in these variables. I'm going to do this by hand, actually. Some of this I'm not going to have to specify again. Well, yeah, I'll just do it all. Um, And here's why. So we're going to need a TX in, a receiver address. Quantity is one. Um, Policy ID, token X, mint
Uh,
script file path, deadline slot, and we've already got sender loaded in, I think.
yeah, you're just going through all the different
Yeah,
variables.
so I'm going
And
to grab all these because this script right here automatically generates new ones. What I want to do is reuse all of those.
yeah,
Okay. So what were they? Well, we need a, we're going to come back to that in just a second. We need the policy ID. Oh, it doesn't autocomplete. All right, we're going to need that policy ID. We need the,
It's because the script will generate if you use again the script will generate updated conditions, and one of those is
exactly.
the time slot, right?
Yes. Yes.
What you
But
want to do, and yes, what you want to do is what you are doing is recreating the previous conditions and test that previous scenario, right?
correct. Correct. But there's something really interesting that happens here. That's unusual if you've been following with some of the examples before. Receiver address. Do I have sender locked in? No, I don't. Okay, let me grab that. Uh, Here's my sender address, which I'm also going to use as receiver address. Okay. And let's query this one. Um,
So for our students watching this video, just pay attention to this process because that's the process you have to do if you want to recreate again a previous scenario.
Here's a nice big UTXO. This would be my greatest Lovelace only UTXO if I was using the utility script. And it was at index 1. Okay. And then some token, the token name can actually be anything. I'm just going to make it 4444. Fine. It doesn't, that token name doesn't really matter. There's nothing validating there. So now if I take all of these variables and I drop them into my terminal here, oops. Oh, you know what we're going to do? Uh, why can't I paste that? Copy. It's not defined. Well, let's do this. Can I do it now? There we go. Okay, so set those variables. the transaction build, oh, let's do it correctly, is going to work. Oh, except that that script doesn't exist. What's the name of the script? Oh, I'm not in the right directory. Right on. Let's go into module. I was working from here, right? And then I have to go into here. There we go. All right, let's paste that again. This transaction actually builds. It's a valid transaction. Why? Well, because we specified some rules in the mint script file. And then we followed those rules. We built a transaction where the deadline slot matches what was in the script file and where the proper required signer is here. If I change that deadline slot to a number that's greater than the deadline here, so 9,700, right? If I change that deadline slot and then I try to build this transaction again, no, it still works anyway. Okay, because it's not confirming at this stage. I thought that was going to fail because this didn't match this, but it's not exactly like um, it's not the same thing as a validator script. I'll explain more about that in just a second. So let me go back. This once again, I just repeated this transaction right here. This should be valid. Where the failure happens is not here. And it's not here either. I have sender key set up, but I have mint signing key file path set up. I just need to enable my sender key. Let's pull this over here while we're here. So we're also going to be able to sign this thing. Oh, let's do this correctly. And let's go back into that directory. So we have a draft of the new transaction in here. There's our new draft. Let's try to sign it again. The way we sign it is like this. That part's okay too. However, if I try to submit this transaction again, I get a really nice new error. Error while submitting transaction. UTXO failure. outside of validity interval UTXO. Okay. We needed to be before this slot as specified here, but the current tip of the blockchain is here, meaning that even though we could build this transaction again, the blockchain won't accept it, right? And so if you can replicate this by minting some new asset and then showing that it's impossible, you'll have completed this lesson. And so the rest of the documentation is here, and we've gone through step by step here, right? We have a Cardano node running. I showed you how to pull the latest changes. We inspected this script file. We talked about how to set sender and sender key either by hard coding them or starting to use an env.sh file, which is a really nice best practice to be aware of. We ran it and it worked. And then we ran it again after the deadline and it didn't work. So you could try the same and repeat these steps like I just showed. Now, that might be an NFT. You can find this policy ID on preprod.cardano scan, and you won't be able to mint it again. Very exciting. Okay. But maybe like a lot of people, when you think about NFTs, you think about images. So that's the next thing we're going to look at. What's nice is I know we spent a while on the previous lesson, but a lot of the patterns that we just used are going to repeat. So prerequisites are the same. What we're going to do is mint a classic Cardano NFT by following the standard outlined in SIP25, which suggests that we can use metadata like this. Here's the label. To mint a Cardano NFT that follows this standard, the label has to be 721. And then the rest of this metadata object, everything between these curly brackets, has to follow a very specific format. First, we have a key representing the policy ID. This has to match the policy ID that we just generated. There's a new object here. This object can have many asset names. We're going to create one that just has a single asset, but it's possible to have a whole list of these with new asset names. And that's how you can generate a single minting transaction with many NFTs in it. Okay. Each of these is going to have a unique name, a unique image. The media type will be consistent across the entire mint. The description can be whatever you want, and it might be same or different depending on your goals. Files, this is optional, but really recommended to include it. This is what allows us to have like a thumbnail of an image and a higher quality, maybe full-fledged image. I don't usually distinguish between these, but if I was building a production grade NFT series, I would want to have a high resolution image here and then maybe like a lower res image here that can load quickly into somebody's wallet. And then you can see right here, other properties. This can be anything. And this is where NFT creators have expressed all sorts of great ideas, right? We can put rarity and traits and all that. As long as it's structured like JSON, you'll be able to use it. We're not going to do that part here, but if you're interested in it, this can be a really nice thing to explore. In the next lesson, we are going to claim that metadata that follows this standard can't be updated, which is a little bit misleading. We can use this version right here to advance the version number of the artwork on an NFT, but it doesn't remove this data. It just replaces it. And that's how the standard works. We seek the precedence of the greatest published version ID. at the metadata key, at a particular policy ID, and at a particular asset name. Now, why does this all work? This works because app developers have decided to follow this standard. It's arbitrary that this exists, and there's nothing on the blockchain that insists that metadata look like this. What does insist that metadata looks like this? Wallets, applications, exchanges, right? Anywhere that is presenting this data in a user-friendly way is safe to assume that the creators of an NFT followed this standard. That's what makes it a useful community standard. But there's nothing on the blockchain like there is for inline datum or reference inputs, for example, that says we must follow this. It's just that if you want the pretty picture to show up in your wallet, yeah, you have to, because that's how tools are built. So in the same way now, we can follow through on a transaction build, right? We've already seen how to mint tokens in the previous module and even in the last lesson, 203.1. All we're going to do here is add one line, some metadata JSON file. And that's what you're going to see in this example. We're going to take two steps here. First, we're going to just experiment with preparing metadata. And then we're going to use the script that looks somewhat similar to the one we were just using to mint the NFT. To use this script, there's an example command down here. And this one takes 4 arguments as compared to the previous example where all we needed was the address. 1, 2, 3, 4. Where are these? They're at the top of this script file. The receiver address is argument number 1. That means it's the first thing we add after the file name. Then, oh, and I have to update this comment right here because it doesn't have all of these. Okay. The second parameter is the name of the token. Maybe we can name one after this lesson. Then we have some art. In most NFTs, this is going to use some kind of perma-web storage like IPFS or Arweave. And just like I can add any arbitrary URL, I could also add IPFS : / and then the content ID of a file on IPFS. And you can explore those documentations. That's one of the assignment suggestions you'll see at the end here. But just know that really the URL doesn't matter, okay? It can be a Web 2 URL like this one, or IPFS, or an Arweave address. And then here's some description. This is going to end up in the description field of the metadata. Now, after we define all these things at the top level, we're actually going to pass them as arguments to another script. So remember how we sourced the env and the utils, right? This is so that we can have some secrets like the path to assigning key. This gives us some helper functions like get address biggest Lovelace. But in addition to sourcing other files like this at the top of a script, we can simply call other scripts throughout our work right here. That's what we're doing with Cardano CLI. Hey, call this other program called Cardano CLI, do the transaction policy ID thing, and output a file. Then use that file. So right here, you can see that we're actually pulling in another script that's provided, and we're passing it as well a policy ID, a name, a URL, and a description. Let's play with this guy first, okay? That's step 1. So I'm going to exit out of this example from the first lesson. And you can see that there's another example right here, mint NFT with image. I just had this on the screen. But before we play with that, we're going to mess around with write NFT metadata. Let's open that one. Okay, so what does this do? There's the 4 arguments that we just looked at. And these are pulled in to this nifty echo trick again that outputs a metadata JSON file. And this right here follows what's described in SIP25. It doesn't do all the fun other properties stuff. I'll leave that to you as an exercise to play around with adding traits or colors or anything else if you'd like to. This is a bare bones NFT minting policy. We create a new file and then we're going to use it. I left this here. This shouldn't be here. Okay. Oh, I know why that was there. All right. So let's use that script first just to see what it does. Okay. So write NFT metadata. A policy ID is usually a 56 character string, but this script is not validating any of that. So I'm just going to make my policy ID like AF, just so we can see it. Okay. What's the next argument? I'm just checking my notes. It's the name of the token, right? So we'll just say my new token name, so it's easy to identify. A URL, example.com, image.png, and a description with a lot of exclamation points. Okay, so what's this going to do? It's going to write a new file called metadata dash my new token name, because that's the param I put right here. Let's look at that new file. And what you see right here is that we have the 721. We have what's not really a policy ID. This is just showing how it works. Now we have a token name, and then we've got the metadata associated with this policy ID and token name. The description didn't work correctly because it terminated at the space. Okay, so I got to fix this script. We would rather have a description here that was that full string. And I see that the provided script didn't work. I'm not going to troubleshoot that live right now, but that's a nice thing that we can fix. And if you're watching this video, I encourage you to take a look. Now, another thing that you'll see here is that this image string is now in some hard brackets. That actually doesn't make a difference in terms of the on-chain functionality. But what this accounts for is how strings are handled in transaction metadata. The maximum length of a string is 56 characters when it's included in metadata like this. The problem is many URLs or IPFS URIs are longer than 56 characters. When that's the case, what you can do is you can split the string up into a list of strings, none of which exceed 56 characters in length. And just to show an example of this, let's run the same example again. My new long token name, right? And right here, I provided a silly example of like a long URL in the lesson notes. Let's just grab this guy. I don't know why that's showing up there. How's that? There we go. All right. So what you're going to see if I now metadata, my new long token name. Yeah, the description's still not working, but you can see right here that we are splitting up that URL into the first 56 characters and then the rest. And if this was a real URL, this would work on chain. Great. At the end of the day, because the script is already written, it's pretty straightforward to use it. I'm just going to copy from the course notes this command right here. Here's the name of the script I'm calling. I'm going to send it to my browser wallet. I'm going to give the token the name lesson 2032, and I'm just going to throw a Gimbalabs G on it. And I'm pretty sure this example message is not going to show up correctly because spaces are not accounted for in my helper function. But for demo purposes, this will be fine. You can see that it works. And once again, first, let's review what happened. We already talked about these 4 arguments. We're generating keys just like before. We're saving the script path and the signing key file path just like before. But we're using a trivial minting policy. This one is just like in module 202 when you learned how to mint tokens for the first time. And notice that this no longer has the deadline part. Once we have that script file, we save the path as a variable, and we pass that path to the transaction policy ID function, which can output a currency symbol. And there we go. That's our policy ID. The rest of this looks just like the previous example, or this part. The metadata is generated here. We just looked at that and compare this to the transaction we were just looking at. There's no validity interval on this one, so we don't have the invalid hereafter part. Where can we see that? Right? There's no invalid hereafter deadline slot like we saw in the previous example. I know that's really small. Right? So we're skipping this part. But we're including this time the metadata. And here it is once again. Okay. We still need a required signer because that's what's specified in our policy ID. We get both signatures and we mint the transaction. And let's see if this token is visible. So I just received a lesson 2032 token. There's actually the time locked token that we were talking about earlier. Here's the lesson 2032 token. And if I look for this one, you can see that it has the Gimbal G attached to it. And here's the metadata we just published. Okay. Cool. So that's another script to play with. Of course, when you use it, you might want to send it to an address that you have access to so that you can view it, and you can replace the image URL with any other one that you want to. And you'll know you're successful if, like I just showed you, you can see that image in your browser wallet. We're not going to have time for lesson 203.3 today. We'll pick up with that one tomorrow, which is fine. But I hope that these 2 lessons made sense. And I'd like to just prompt everybody to think about this. Did we just mint an NFT? Do you think that token was non-fungible? Why or why not? And if you have answers now, or if you want to start dropping them into the chat here, this can be an ongoing conversation. But to close out, does anybody have any initial thoughts? Which one of these is more of an NFT? the token we minted in lesson 2031 or 2032? Harsh is laughing.
Which one is more of an NFT, which is interesting.
Yeah.
I think the one that's like with the deadline, meaning that it can't be minted again. I mean, the 721 one that we can mint on on the same policy. So they're semi-fungible. So maybe that's where that gets to. I think that's a term.
Sure.
Fungible,
I think we should mint that
non-fungible.
term if it's not yet.
Yeah,
Semi-fungible.
yeah.
SFTs.
Oh, no. I can't get behind any more of that, but uh,
Right.
but yeah,
Yeah.
I mean
Anybody who grabs this signing key right here could just mint more of these tokens. Nothing could stop them. It has pretty picture. It's a really beautiful G logo, but right, it can be minted again.
Oh, and that's not that what was interesting to me was the metadata, I guess the 721 stuff, uh like that is not on the chain. That just is a standard because of like it's a community standard. We all agree, and if you break from the standard, then the apps and things won't work. But there are other things that are on chain that are, for lack of a better term, hard standards, meaning that it doesn't matter if other people use it or not, it's not going to work because of the chain itself, of Cardano itself,
The
is
rules,
not
yeah.
accepted.
Yeah.
And it's sort of like Cardano, the chain, being like a super user. And it's sort of because it can change. Like if it was just a community member and it just says, okay, now we'll change. But it's a more hard rule. Uh, yeah. I thought that was interesting. I thought that was interesting.
And just to be clear, like the metadata does go on chain,
Yes.
but there's
Yes.
no rules about what precisely it must look like.
So I could build a sender and a receiver that both said, we're fine to accept this data in this style,
Mhm.
But if we tried to use another sender or another receiver, then if it didn't use the same style, then things would break.
That would be an interesting system,
Yeah.
right? And now you'd be talking about something that goes a step beyond what we have right here.
Yeah. Yeah.
And so, like, for a really trivial example, image. I don't want to type the whole word image. I just want to use IMG like we
Yeah.
do in JavaScript. Like, I could do that and it would go on chain. But then if I tried to look at my pretty picture in my wallet, it wouldn't work. Why? Because the standard says you got to use this as the key.
Because the wallet is expecting something that says IMAGE,
Right.
and not IMG. And so it's going to get
Right.
to that part. It says, well, we don't see it. So we're not, and depending on how eloquently it breaks, it could just break. It could just not show the image or it could just pull it all down. Yeah.
Could I build a lonely little tool that does read IMG and it only works for me? Yeah, I
Yeah.
could. But would I be part of a community? No, not really.
What do you call it? Lonely? You're the part of the lonely little app
My
community,
lonely little app.
community of one. That'd be fun. All right.
All right. So one of the assignments, all right, the neat stuff is to combine what you just saw in those two lessons to try to get both a time-locked NFT that also has a picture. And that's a nice exercise to try to get there. Optionally, if people want to explore IPFS, this is a chance to do that. And hopefully, based on what you just saw, you have some ideas about how you could get some more basic metadata onto the blockchain in this case at this key. You're going to learn a little bit more about how to possibly do this with mesh when we look at tomorrow's example. All right. And we'll pick up right here, same time tomorrow, where we're going to be using 3 different repos at once. We're going to look at Aiken to talk about the minting, or sorry, the validator policy itself. We're going to use the front end to build some components that will allow us to interact with this. And then we're still going to be creating some pretty trivial minting policies so that we can connect some dots there. This is what we'll pick up with tomorrow. Originally, the ambitious plan was to get to module 204 for tomorrow. But I think it's nice to kind of do this deep dive together. We'll seek more and more brevity as we refine these videos. But if we finish this guy here and then 204, this can happen next Tuesday, same time, same place.
Hey, James.
Hi,
I
Sean.
have a small suggestion which doesn't need to be taken seriously, but I was thinking, what if just while you are going through the modules this way, what if we take like 10 minutes and actually do the stuff that you're teaching, just so we can all be on the same page and stuff. I don't know, it's just an idea to think about.
Let's aspire to that. Let's get there. Yeah, I think that's the system we want to build. And that was an idea that came up at Open Spaces recently, right? Is having more time to get together and work on the assignments. Let's try to create those. And I was trying to move fast because I had the harebrained idea that we would get through all three of these lessons in 90 minutes. That was going to be hard no matter what. But this slows us down. So tomorrow, if this is the only lesson we have to do, let's follow that suggestion. And so if anybody wants to, maybe in advance, just make sure you have these 3 repos pulled down and up to date. And then let's spend some time, like working through this for anybody who wants to give it a try.
Thanks, y'all. See
Rock and
you.
roll. All right. See you
Oh.
tomorrow. Thanks, y'all.